In this video, we're going to look at some more trigonometric identities. So let's take the first example. We need to prove that this identity is identical to cos cube theta. So what we're going to do is we're going to change everything to sine and cos as a general rule. So cot theta is the same as cos theta divided by sine theta multiplied by 1 over sine theta, because that's what cosec theta is. And then on the denominator, we're going to have 1 over cos squared theta. And then cosec is 1 over sine, so that's going to be plus 1 over sine squared theta. So on the numerator, I can see I've got cos theta all divided by sine squared theta. But then with the denominator now, I need to make these two fractions the same. So I'm going to times this by sine squared theta, times this by sine squared theta, times this by cos squared theta, and times that by cos squared theta. So what I end up with is sine squared theta plus cos squared theta all divided by sine squared theta cos squared theta. But we know that sine squared theta plus cos squared theta is 1. So we could rewrite this as follows. We could write it as cos theta over sine squared theta. I'm going to write a normal divide sign here. Well, sine squared theta plus cos squared theta is 1 over sine squared theta cos squared theta. Now, using the laws of fractions, we could say that's the same thing as cos theta over sine squared theta times, turn the fraction upside down, so we get sine squared theta cos squared theta over 1. Then the sine squared theta and this sine squared cancel out, so I get cos theta times cos squared theta to give me cos cube theta over 1, which is identical to cos cube theta, which is what we have on the right hand side. In the previous example, we just showed that this identity was identical to cos cube theta. So we need to show why this identity equal to 8 has no solutions. So we showed that this was identical to cos cube theta. So cos cube theta equals 8. So if we were to cube root that, we would get cos theta is equal to 2. Well, this is invalid. Why? Because from the cosine graph, so if we were to draw a cos graph here, that you would know that the range for the cosine graph is as follows. It's only valid between 1 and -1. So the 2 is not accounted for. It's not within the range. So we say because cos theta is only valid between -1 and 1. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we need to prove that sin x tan x over 1 minus cos x minus 1 is identical to sec x. So let's change everything to sine and cos. So we get sin x times, and I'm going to write tan x as sin x over cos x. Now, initially I'm going to ignore the -1. I'm just going to deal with the initial fraction. So 1 minus cos x. So we'll deal with the -1 later. So what we have is the following. We get sine squared x divided by cos x on the numerator. And then I'm going to write divide 1 minus cos x, which is what we have on the denominator here. But I'm going to write that over 1. So what we're going to get is sine squared x over cos x times 1 over 1 minus cos x. So what happens is we get the following. We get sine squared x over cos x multiplied by 1 minus cos x. Now that's the first fraction that we have. Now I need to subtract 1. So I'm going to write what we have. So we get sine squared x over cos x times 1 minus cos x. And now we're going to subtract 1. But this is 1 over 1. We need to make the denominators exactly the same. So I'm going to times the denominator by cos x times 1 minus cos x. The same thing here. Cos x times 1 minus cos x. So what happens now? We get the same denominator. So we're going to get cos x times 1 minus cos x on the denominator. Then on the numerator, we need to be careful. We get sine squared x minus 1 cos x is minus cos x, right? So minus cos x times 1 will give me minus cos x. Now be careful, minus cos x times minus cos x is plus cos squared x. Now sine squared x plus cos squared x is 1, so we're going to get 1 minus cos x. Now I'm going to write it in this form. So cos x times 1 minus cos x. But we've got the same factor appearing twice now. And they're being multiplied on the denominator, so I can cancel them. So this and this cancels out. They're going to be 1 and 1. So I'm left with 1 over cosine of x, which is sec x. Now for the second part of this question, it states, explain why sine x tan x over 1 minus cos x minus 1 equals to a half has no solutions. You could try the question, pause it, and watch my work solution. So this is similar to the example that we did. Well, we already showed that this was identical to sec x. So what we have is sec x is equal to a half. Well, sec x is 1 over cos x. So we can cross multiply. Bring the 2 here, bring the cosine x there. So cos x is equal to 2, which you know is invalid. As shown before, the cosine graph is only valid between 1 and minus 1 for the range. So we can say, since cos x is only valid between minus 1 and 1, therefore this has no solutions. Therefore cos x equals 2 has no solutions.